First question looks at comparing these four fractions. So we've got common fraction, mixed number, and then we've got two decimal fractions. And we need to convert those to be similar in order to do the comparison, and ask them to list them in order from smallest to largest. Okay? So how I look at this question is, we know that the whole number here, 3, okay, from a comparison point of view, is going to be further along the smaller number, so further along the number line than the negative, compared to this one here, -1, and this one here, -1. And we know that this one here, -1/4, is going to be this side of the -1 for there. So the only two that we actually have to do a comparison on is this one and this one. They're the only two, because the other two are well outside that bound, okay? So what we're looking for here is the idea that 1.5 is the same as -1.5, and we can see that here -1.5 as a fraction would be 4/8. Okay, so we know now from this that -1 5/8 is actually a bit smaller, so it's a bit further along the negative side of things. Okay. So we don't actually have to find common denominators for all of these. You could, but it's not necessary. So if we're looking at which one is the smallest, -3.12 is the smallest, okay? And that will become apparent because it will go obviously onto a number line about there, -3.12, okay? And then the next smallest will be -1 5/8. So here's -1.5 is here, all right? Now that will be -1.5. And then just smaller than that, and let's do a little, will be -1 5/8, is just smaller than that, okay? And then -1/4, okay, here's half, so there'll be a quarter, so that'll be there, that'll be -1/4. And that's our four things in order, smallest to largest. Now, if you were asked to write them smallest to largest, okay, then as a list, then it'd be the same order: -3.2, -1 5/8, -1.5, 1.5, and -1/4 would be to write them all in order smallest to largest. So here we have cube root of 8. Okay, so the cube root of 8. So this is what basically the answer is 2, but it's 2 by 2 by 2 equals 2 cubed. So 2 cubed becomes 8 equals 8. So therefore the cube root of 8 equals 2. Okay, so that part of this equals 2. And then -1 cubed is -1 times -1 times -1. Okay, so 1 times 1 times 1. So the answer is going to be obviously 1, and you just got to decide whether it's going to be negative or positive. Well, it's a negative times a negative is a positive, times a negative is a negative, so it becomes take away 1. Okay, so this subtraction stays, this one becomes a negative, so that becomes 2 plus 1, and so the answer is 3. So here, using bodinus again, so it's the negative of the square root of 9, which is 3, and then take away 2, okay? And that's all in brackets, okay? Divided by 5. And so -3, take away 2 becomes -5. So -5 divided by 5 equals -1, okay? Because -1 times 5 equals -5. We can see here we've got a negative and a positive, okay? So we can do those ones left to right, and then we've got to resolve the brackets first, okay? So the rule here, A over B, x equals A to the x over B to the x. So always make sure you make use of the formula sheet for these types of questions, okay? Because otherwise you might just be guessing. So now we can see that the A in this one is the 3 here, so it becomes 3 squared, okay? So that becomes 3 squared over the top of 2 squared, Okay, so 3 squared is 9 over the top of 2 squared, which is 4. Okay, so we've got now -2 take away a half. Okay, so that becomes -2 and a half. Okay, and we've got to add on to that 9 over 4. Okay, so 2 2s are 4 and 1 is 5. -5 over 2 plus 9 over 4. And then we need common denominators at that point, so that one here will be times by 2 times by 2. Okay, so now that's going to equal -10 over 4 plus 9 over 4. 9 over -10 plus 9 is going to equal -1. That's going to equal -1 over 4, so -1/4. Here we have a series of rectangles. This one here is labelled A. This one here is labelled B, and this bit here is seen as the shaded area, okay, where obviously A and B are the shaded area. Okay. The first thing it asks us is to create algebraic expressions for the length and width of the shaded area. Okay, so we need a width of this part here, okay, and then we need a length of that part there. Okay, so let's do the length first. So the length is that length, so it's 3x plus the 2. And now the width, so the width is this distance all along here, take away that bit there, because that leaves you that bit here, okay? So that becomes 3x take away 7. Now it says write an expression for the area of this here, okay, of A and B, right? So so what we can do here is we can now add that. So this is 3x minus 7. Is this bit here? Okay. And so we can see here that A is going to be length times width. So it'll be so A will equal 3x minus 7 times by 2. Okay, and we're going to put that in brackets to protect it. Now, obviously, we would rewrite that as 3x minus 7 to have it in that more algebraic format. Okay, and then part B would be the 3x, and that would be multiplied by this length here. Okay, which is 3x minus 7. Okay, again, we'll protect it like that, and that becomes 3x minus 7 as such. Now, that's the area of B, and that's the area of A. Write an expression for the total shaded area. Okay, so those combine, and it says to expand and simplify. Okay, so if we know it's this one here and this one here, so we need to add those together. So it's 3x minus 7 plus 3x minus 7, like this. Okay, so we've got the area of A here, and we've got the area of B here. So that's the area of A, that's the area of B, and so we need to add them together in order to find the total area of A and B. First thing we need to do here is to expand our brackets, okay? And then once we've expanded our brackets, we will then collect like terms and solve. So 2 times 3x is 6x, 2 times -7 is -14, plus 3x by 3x will be 9x squared, and 3x by -7 will be -21x, okay? So now we want to gather our like terms, okay? So let's put, so 6x, take away 21x, take away 14, and plus 9x squared, okay? So that gives us 6 take away 21 will give us -15x, take away 14 plus 9x squared, which we can rewrite as 9x squared take away 15x take away 14 in order to have it in the correct order from an algebraic point of view. Okay, so 5y over 12 take away 3y over 10, so this is the common denominator question, okay? We have different denominators and we can only do subtraction of fractions if we have common denominators, okay? So common denominator here would be 60 for both. So we want to multiply that by 5 and multiply that by 5. So we've done to the bottom, we do to the top. And we want to multiply that one by 6 and that one by 6. Okay? So we end up with with these common denominators of 60. Okay? 5 times 5y is 25y. Take away 6 times 3y is 18y. 25 take away 18 leaves 7y over 60. Okay, so here we have an expression on top bottom of this fraction, and what we want to do here is to cancel. That's what yells at us here. We want to cancel in order to solve this. But we can't cancel because we've got this addition. We have to have multiplication in order to cancel. So what we're looking for here is to factorise. Okay, so we're looking for something that is common to both of these expressions, okay? And we can see here that x is common to both, okay? So x will be common to both, and then we can see here that 8 goes into both these numbers, okay? So positive 8, like this, okay? And then what we can look there now and see that, okay, so what we have a problem here though is we can't put 12 and 9 out the front, okay? So we can see here that 3 is also common to both of those, okay? And so now we end up with 3x plus 8 over 3x plus 8. Now, we've got one more step to do before we finish factorising, and that is 4 times 3x gives us 12x, and 4 times 8 gives us 32. And 3 times 3x gives us 9x, and 3 times 8 gives us 24. So now we've got factorised top and bottom, okay? And what we can do here is, because we know that with this scenario in algebra that there is a multiplication in here, okay? That means we can cancel that 3x plus 8 with that 3x plus 8. And that leaves us 4 over 3, okay? Now you can leave that as that in this scenario, or you can simplify it to 1 and 1/3 if you wish to. Okay, so here we have just a multiplication question with some a and b, and we have an a to the 0. And if on our formula sheet it tells us that a to 0 equals 1, okay? So what we can see here is that becomes, we can replace that a to the 0 as 1. So it becomes 4 multiplied by 1 multiplied by b is what that becomes. So that effectively becomes 4 times 1 is 4, times b is 4b. And then we're multiplying that by negative 6a5b. So we can just put negative 6a5b like that, okay? Because here it's effectively a 1 times each of those. There's nothing else to resolve there, okay? Now it's as simple as going 4 times negative 6 is negative 24. There's no a that multiplies, so that just stays as a to the 5, and b times b is b squared. Negative 24, a to the 5, b squared. So we had this question given to us, and we need to go to our set of rules to know that a to the x in brackets to the y equals a to the xy, okay? So what that means is that when we're trying to resolve this bracket here, we're going to be multiplying the 2 by the 1 that's here, even though it's not shown, and the 2 by the 5 that's here, okay? So that then creates this scenario. So we have negative 4 squared, so that becomes 16. A to the 5 becomes a to the 5 times 2, so a to the 10. And n to the 1 times 2 becomes n squared. And that's all over 16 a5n, okay? And that's multiplied by 3n over 15n to the 5, okay? So we've now got rid of the brackets, now we can do some cancelling, okay? So we can see here that we can cancel that 16 with that 16. We can cancel that 5 there, okay, with 5 of those, and we can cancel that m with one of the m's here, okay. We can cancel that 3 with that to give us 5, and we can cancel that m with one of those to give us 4, okay. So now with reading across, we have a to the 5, m to the 1, so a to the 5 and m to the 1, okay, over, okay, and we got rid of all of that, so that's over 1, multiplied by 1 over the top of 5, m to the 4, okay. Now we can also cancel here, so we can cancel that m with one of those, that kind of goes to 3, okay, and then we can, across a 5 times 1 is a to the power of 5, all over 1 times 5, m to the 3. Okay, change of venue. So this question looks at this idea of an outfit, and it gives us some items in that outfit. I think crucial in reading this question is to carefully read where it says things using of. So for example, it tells us the cost price of the shoes, $340, so there's a bit of key information. Then it tells us this statement here. The cost price of the dress is 300% the cost price of the shoes. And that statement on its own gives you the equation, okay? So 300% of the cost price of the shoes, which we know up here is $340. So that gives you your equation, and from there it's just a case of 300% is 300 over 100, of is multiplication, and 340 over 1, okay? And so once we get that, we can then do some, obviously cancel those two zeros with those 2 zeros there, and it becomes 3 times 340, which gives us an answer of $1,020. Okay, so that's really the reading of that question. Okay, the next question tells us to find the cost price of the hat, and it tells us that it's 40% of the cost price of the dress. Now, the cost price of the dress we found in part A, so that value there is $1,020, okay? So now, exactly like the first question, part A, we've got our 40%, so it's 40 over 100, of becomes times, and 1,020 over 1, and again, we can cancel that 0 there with that 0 there, that 0 there with that 0 there, and we end up with this 4 multiplied by 102, okay? And that gives us 408 as our answer for the cost price of the hat. Okay, part C asks us to find the percentage of the cost price of the shoes compared to the value of the entire outfit. Now, both these bits of information are given to you in the paper. So it's really just a case of making a fraction out of those. So really, a percentage is what fraction, okay? So we have here 340 over 2,000, and to turn any fraction into a percentage, we simply need to multiply by 100 over 1. Just like in the previous couple of questions, we have the 2 zeros here, we can cancel the 2 zeros there, and we have 1 0 there, we can cancel 1 0 there, and then we have 34 over 2, 2 goes into itself once, 2 goes into 34 17 times. So now we end up with 17 multiplied by 1 is 17, and 1 times 1, so we can ignore that, and that gives us 17, and it's a percentage that we're being asked for. Make sure that you refer back to the question, because what we saw sometimes here is that students, because they've done dollar signs in the previous 2 questions, will put a dollar sign in front of this. just always understand what's the question asking you to actually give as an answer, and make sure that you put the correct symbol next to it. Part D asks us to find the selling price of this outfit. And so what we need to consider for this are two factors. Firstly, what's the markup? So this is the profit that the seller is going to take. And then we need to add on to that GST. So here we can see that the markup's 70%. So the final price is going to be the cost price plus the markup. So the cost price is going to be 100%. So 100% of what you pay for something, plus the markup that the person has put on that item. In this case, it's 70%. So that gives us a total markup of a total price of 170% of the cost price. Okay, which in this case is a $2,000 outfit. So now we can use this statement here to create our equation. So 170% becomes 170 over 100, of becomes times, and then 2,000 over 1. And again, so 100 goes itself once, and then we cross out 2 zeros here. And then we end up with 170 times 20, okay? And that's going to give us our final price here, which is $3,400. $3,400. So that's the first part of that particular question. The second part then asks you to add on the GST onto that. So you need to add on 10% of this. Now, most students are going to be able to look at that $3,400 price and go, well, no, 10% of that's going to be $340. So they're simply going to go plus 340, okay, and that's going to give them a final price of 3,740. You could go through the process of going 10% of 3,400 and go 10 over 100 times by 3,400 over 1 and go 10 times 34 is 340, and then add that on to do it that way. But most students would just look at 10% and know how to work that out because that's part of our course of study. Okay, so now we have a series of angles we need to find from a variety of questions. So the first one looks at this. So the idea here is to realise that you have this straight line here. Okay, so therefore the angle that goes around here has to equal 180 degrees. Okay, equals a straight line. And so therefore 180, take away 40 plus 60. Will equal A. So therefore A equals, well, that's obviously 100. And we just take that there. So 180 take away 100 is going to leave us with 80 degrees. Next diagram looks a little bit complicated. So the idea here would be the first thing, before you start trying to tackle what the angle is to look at what information that you've been given. So we see here, in fact we have two triangles, okay, one here and one here. And we can see here that we have this matching set of lengths here. So what it tells us is that this triangle here is an isosceles triangle. And we can see that on the other side, we also have an isosceles triangle. And what we know with isosceles triangles is this, that these sides are the same length and that these angles are equal to one another as well. So what it tells us is that if those sides are the same and those angles are the same, then that 35 here is also a 35 in here. And it's also a 35 in here. And a 35 in here. Like that. Okay, now, once we know that, we can then go to the idea that every triangle is equal to 180 degrees in total degrees. And we have here 35 and 35. So 35 and 35, 70. So 180 take away 70 is going to equal 110 degrees. So that tells us that in here, it's 110 degrees in here. And it's 110 degrees in here, okay? So now we can consider that this is actually a full revolution here, okay? And we know that a full circle adds up to 360 degrees. So 360, take away 110 plus 110. So 110 plus 110 is 220. So 360 take away 220, going to leave us with 140 degrees. So therefore T is going to be equal to 140 degrees. Okay, the next question has these two parallel lines here. Okay, so what we can see here is we have 81 degrees here and we have a corresponding angle which is x. So simply we can say that x equals 81 and we would give the reasoning that it is corresponding in this particular diagram. Last one diagram has this sort of quadrilateral shape with these crossing lines here. And what we know with the crossing lines here is that anything here is going to be vertically opposite. So here we can see that M is vertically opposite 131, so therefore M equals 131 degrees. We can then use that bit of information to consider the quadrilateral, and we know with a quadrilateral that it has to add up to 360 degrees. So now we have 360, take away 131, which we just found here, plus 103, plus 83. Okay, so, and that adds up to 317. So 360, take away 317 is going to leave us with 43 degrees. N therefore equals 43 degrees.